Hello everyone, welcome back to Finitechos. So in previous video, we have built a complete rack pipeline. So in this video, we are going to discuss about advanced rack techniques which are used in production level AI systems. So without wasting any time, let's begin. So our first topic is hybrid search. So imagine we have data like this, and if we ask a question, tell about employee. So if we ask like this, what does it use? Obviously keyword search, because we have given a particular keyword and it searches according to it and gives the data, right? So, what if we ask, tell about the department of employees? What type of search this uses? Obviously, vector search, because this can only understand the meaning and it doesn't contain any keyword, right? So, this uses the vector search and this uses the keyword search. So, what if we ask a question like, tell about employee EMP 102 and tell their department. So, what should this particular query use? Obviously, it need to use both keyword search and vector search. So, the combination of both keyword search and vector search is known as hybrid search. Got it? Keyword search plus vector search. Hybrid search. Right? So, let's implement this practically. So, I'll create a file called hybrid search. Now, let's install this particular libraries. LangChain. Enter. Now, with space LangChain dash community. Okay, now we need to install the Gemini SDK. Let's install FAISS. Okay, this library will be used for keyword search. Yeah, it's done. So now let's import these libraries from LangChain underscore core dot documents import document D capital. So this will be used for creating a document. So now let's create our document manually instead of taking it from somewhere for better understanding. So now let's import Google Gemini from LangChain, Google Gemini, import Google Generative AI Embeddings. This will be used for creating the embeddings. So from LangChain, community dot vector stores, import FAISS So we all know that this is a vector database which searches the information by meanings. So we have imported the vector search. Now we need to import the keyword search. For that, from LangChain community dot retrievers import BM25 retriever. So for keyword search, we'll use this. So for combining this vector search and keyword search, we need to import another library called ensemble retriever from LangChain retrievers. Mm, mm. I think it's not underscore. Yeah, it's dot. Import capital E and SEM BLE retrievers. Got it? Since my ensemble retriever is not working properly, we'll not use it, guys. We can also perform operations without it. That's not a problem. So now we should import OS from .env import load underscore dot env, right? So this will be used to protect our API key. Now load underscore dot env. We need to load it. Now we need to insert our API key, guys. Gemini API key. Yeah, I think Google is better. Fine. equals to os dot get env. So inside this parenthesis, we need to insert our API key. So inside my Google AI Studio, here's my API key, guys. I named it as RAG API. So let's go to VS Code. I'll paste it here. Yeah, fine. So before implementing the hybrid search, we need to create a document, right? So let's create a sample document by ourselves. Documents equals to document where D is capital here. Okay, we need to insert. Yeah, should be like a list data structure, guys. Okay, this looks good. So we need to give the page content here, page underscore content equals to. So let's take a reference of this. Hmm, okay, we'll create our own one, guys. Employee EMP001 works at AI department. Yeah. So let's create another page. So here the content should be okay. I'll insert a comma here. Here the content should be 02. Works at HR department. Right. So again, it's transforming healthcare. Yeah, it's fine, guys. So this is a document. We have created a document by ourselves. Okay, these are three documents, guys. Document one, document two, and document three. Think of like that. So let's print these first of all for testing purpose. For okay, for doc in documents print documents dot okay, okay, got it. Doc dot page content. Yeah. So let's run this, guys. Okay. So these are the three documents. Okay, it's fine. So we need to convert these documents into the embeddings and should store into the vector database. For that, I'll use FAISS. We all know it. As we discussed this in part one, guys. Yeah, right. So embeddings equals to Google Generative AI embeddings. Yeah. So here are models dash embedding dash 001. So this is our model, guys. So now we have created the embeddings. I mean, we have created the embeddings model. Now we have to create the embeddings and store it into vector database. So for that, db equals to, okay, vector db. Yeah, it's good. Vector db equals to FAISS dot from documents. So we need to give the documents which are need to be converted into embeddings. I mean, okay, right. Which are need to be converted into embeddings and to be stored in database, vector database. So I'll give my embeddings model first of all and our documents. Yeah, this is fine. So our documents are converted into embeddings and stored into the vector database. It's completely fine. But for giving the answers, the database isn't enough, right? So we need to find the most relevant chunks and need to retrieve the answers. So for that, we need a component called retriever. So I'll create a variable called vector retriever equals to our vector database vector db dot as retriever. Fine. So imagine you have some documents in vector database, I mean, which are converted into embeddings. So you need a particular answer. So for that vector database alone isn't enough, right? For searching the answers, we need a retriever. A retriever searches all over the database and gives the answers. So for that, we'll use vector retriever. Suppose if I ask, tell about employee 001, it retrieves, I mean, it searches all over the documents and tells that this particular employee works at AI department. Got it? This is what retrieving means. So let's enter a query, guys. So our query equals to some tell about AI. Fine. Yeah. Okay. Tell about our particular employee ID. Fine. Now results equals to vector underscore retriever dot invoke query. I mean, this method takes our particular query and converts this query into embeddings, and it searches for all embeddings in this documents. The nearest embeddings will be printed as an output. I mean, will be returned as an output stored in results, right? So for printing, I'll use a loop, guys. For mm, I in results, print I dot, yeah, page content. So it's fine. Okay, we have also inserted our API key. So let's run it, guys. Okay, so let's try changing our model. I'll change to this. These both are similar models, guys. And mm, okay. Also, let's do one good thing for security purpose. I have created a .env file, guys. So making sure that you create this file and here keep a variable name like Google Gemini API key and paste your API key here. Go to your hybrid search file or your respected file and paste this particular variable name so that it can automatically detect the .env file and takes the API key, which leads to good security, guys. It's fine. So let's give it a try. Okay, I think our API should be something like this. Yeah, something like this. Control S. Yeah, all right. So let's test it. Also, I have changed the model right to this, which is also a efficient model for converting into embeddings. I recommend you guys to use this. So, guys, as we can see here, we got an output like this. We have got this particular employee works at AI department. This part and this part. This means indirectly we got the entire document. Why? Because as this is a small document, it gives the extra information about this particular mm, query. I mean, if we have a big para, imagine it gives the response about that particular query and additional matter, something like this. The next line, something like that, right? So we all know that what is that top K clustering. We have discussed this in previous video, right? So in this way, it gave the entire document, right? But it has given the answer. That's good. So this is known as vector search. Got it, guys? So now let's concentrate on keyword search. Mm, Here I'll create a variable called BM25. So now BM25 retriever dot from documents. Let's give our variable documents. Fine. So what does it do? It retrieves the text from our query and searches through the keywords from our document, right? So it doesn't convert any embeddings. Got it, guys? It is completely different from vector search. So now let's test it, guys. So our query equals to, yeah, this. Now, okay. So our results equals to BM25. Our variable BM25 dot invoke query. Now let's print the output for I in results, print I dot page content. Got it? So let me clear the terminal. Yeah, okay. Yeah, so let's give it a try, guys. I have removed the vector based search, so it's fine now. Okay, so it has given the result like first priorities or query this part, which is okay, good. The second one is AI is transforming healthcare. Okay, nice. Okay, this is the third priority. Okay, it's very good, guys. So this is known as keyword search. So vector search uses FAISS and keyword search uses BM25. Just remember it, guys. So now let's implement the hybrid search, guys. So we have two different types of searching. One searches using keywords and other searches using meanings. Instead of choosing one, so let's combine both. That's what the hybrid search is, right? So here I also implemented the vector search too, guys. So let's do one thing. First of all, I'll print this as something like vector search. Yeah, print keyword search. Yeah, this looks good. And yeah, now let's run it, guys. Okay, again. Oh, sorry, guys. 1 minute. So here the results are there for keyword search, but not for vector search, guys. We have deleted it previously, right? So now let's rewrite it. Yeah, okay. I'll place the query here. This is fine, guys. So let's try. Mm, cool. So this is the vector search and this is the keyword search. So the vector search answer has given like entire document. I mean, all documents in an order, but the first priority is the exact answer, which is good. The same happened with keyword search, but the second priority is this document. Right, calculations may vary, right? So compare this both, guys. Now we need to compare. Sorry, I mean we need to add the both results, guys. So for that we'll use string concatenation. Yeah, I mean we need to concat it, right? So I'll create variable hybrid search is equals to our yeah, results. I'll name these as the results one and results two. And let's add these both. results 1 plus results 2. It's fine, right? Now let's print this for I n hybrid search. Print I dot page content. Yeah, that's it. So let's clear the terminal and run it. Okay. Oh, sorry. I need to rename the variables and loops, right? Sorry, guys. Small mistakes. Yeah, okay. It has given the results for keyword search, vector search. So from this, the content is the hybrid search content. So here we can see that there are duplicates, right? Here the AI department. Again, here it is like AI is transforming healthcare. The same is repeated here. So this leads to wastage of tokens, right? Means it leads to more API credits, right? Here the same document appears multiple times, right? So we want everything. I mean everything from the vector search as well as a keyword search, but not the repeated ones. We need only the unique ones. So for that, we'll use set data structure. So let's create a variable called unique, which is a list data structure. The unique values are stored here, and let's create a set called scene, which is a set data structure. Here, the every element is sent to this particular set. If the values are only unique, then it will be appended to this particular list. So now let's loop for DOC in hybrid search. For DOC in hybrid search, if our particular document, sorry, if our particular document is not in the set scene, then let's append this to the particular unique list. Oh yeah, doc dot page content. Yeah, this is fine. So unique dot append our particular document, right? Also, let's add this into the set scene dot add doc. Yeah, doc dot page content. This looks fine. So okay, so let's print the hybrid results. So now for I in unique, so I in unique print I dot yeah, I dot page. Okay, I think it's a good idea to keep something like this hybrid results. Yeah, this is good. page content. This is fine. So let's remove the loop printing statements here, guys. Yeah, okay. So let's leave this all. Okay, fine. So let's try this. Yeah, this is fine, guys. It has given the accurate result, right? We have asked about employee 001. It has given this as first priority and later give this for extra content. It's good. Yeah, so far we have got accurate results, but we think this may not be the correct answer because it's only just giving the response. A chatbot should give content like an assistant, like giving updates, right? So let's send these documents, I mean, these particular results to Gemini by combining with our query. So let's see. This makes the complete hybrid model. So I'll create a variable with context, which is equals to. So let's give somewhat space, guys. Mm, yeah, this looks good. Dot join. Yeah, doc dot page content. Here I'll create a loop, guys, for doc in unique. Yeah, this should be something like this. It's good. Here our particular document will be stored in this particular context. I mean, are unique, right? So now let's give a prompt, which is equals to yeah, you are a helpful AI assistant, right? Answer the user question by only using the context below. Mm, If answer is not available, just reply answer not available in database. Just for a professional reply. So let's give our context. Our context. In this way, we can give a particular variable. Yeah, and our query. Cool. And let's end this. Good. Now we need to import Google Gen AI. I mean, our Gemini, LangChain, Google Gen AI, import mm, chat Google Generative AI. It's fine. So now we need to create Gemini model. I mean, we need to import a model. So our model, which is equals to chat Google Generative AI. So here we need to give our model. Model equals to Gemini 2.5 Flash. Right. Now also we need to give our temperature. So let's understand what the temperature is. So the temperature controls how creative or random the model responses are. Suppose I set the temperature to 0. The responses will be consistent and predictable and good, but not fancy. But if my temperature is like 0.5, the responses will be good, but somewhat more creative. If my temperature is similar to someone or starting from 0.8, then the responses will be more creative and maybe false responses. So for our RAG model, we don't need any fancy responses, right? So I'll set temperature as some 0.1. It's good. So let's get our response. A response equals to model dot invoke a particular prompt. Sorry, prompt. Good. So let's print our response. Response dot content. Yeah, it's completely fine. So now let's run this. Hmm, okay. So I have changed the model to Gemini 3.5 Flash, guys. So now let's give it a try. Okay. So I have given the query as tell me about EMP 2001 work setting. It's very accurate, guys, as you can see here. So this is the entire hybrid search rack pipeline. Got it? So that's it for today, guys. In this video, we have discussed completely about hybrid search. In next video, we'll discuss about metadata filtering. So bye and Jai Hind.